So good morning students. So this lecture I will explain one problem on acceleration and a problem on instantaneous center. We already discussed problems on acceleration and instantaneous center, but due to some request explain one more problem from each session. Okay, hope this will be enough for you. Else we will add one more video. So this is a question for acceleration analysis. We have an engine mechanism shown that is a slider crank mechanism. Crank is given, connecting rod length is given, a crank length is given, and this position instant crank speed is given, and its angular acceleration also given. Okay. Then radian per second, speed in radian per second, that is omega, that is angular velocity, and angular acceleration radian per second square, it is alpha. And note down, in some questions there will not be angular acceleration will not be given. Instead they may given uniform velocity, or sometimes even that also not there. But if it is not given for the input link, you have to assume it as 0, or that means if it is uniform velocity, angular acceleration will be 0. Then find velocity of slider and angular velocity of AB, that is connecting rod. Also find acceleration of slider and angular acceleration of AB. Okay, and this is the question. So here we have a G, a point. This point you can ignore because we don't need this point. But in the actual question they asked about the point G. But here it is not required. But I didn't erase it. That's all. Okay, we have points A, B, and C only. And the inclination is 120 degree. Direction is given. VB is given to only show the direction. Direction is this direction. That means clockwise. This is the question. So how will you do it for acceleration? So the first step is you have to draw acceleration polygon. You have to draw the velocity triangle. So we'll do that. So this is the space diagram of the given diagram, given mechanism. We have A, B, and C. So you start with a point C, measure 120 degree, and measure CB, that is 100 mm on scale, and draw a line and mark a point B. Then draw a horizontal line from C. Then from B, in compass you measure B, you take BA as the radius and BS center, draw an arc to cut on this horizontal line. That point will be your A, and join A, B, that is your connecting rod. There is a horizontal line, not a link but just a line, or from A to C. You can use a chain line to represent that too better. Okay, here the thickness is different. So this is your space diagram. The next step is velocity triangle. How will you draw the velocity triangle? First you have to find the velocity of input link, that is crank BC. So it is given that crank speed is omega 75 radian per second. Therefore velocity VB will be VB will be its linear velocity. So what we are drawing is linear velocity triangle only. So you should know VB. VB is your input velocity. So VB equal to omega BC into length of BC, because B is the endpoint of link BC. So VB equal to omega of BC into length BC. So omega is 75, and 75 into BC, length is 100 mm. So into 100 mm. So you will get 7500 or 7.5 meter per second. That will be your input velocity. You can note down. Then next you have to draw that. How will you draw? The velocity will be perpendicular to the link, and the direction is shown. So it is perpendicular to CB. So the both directions possible are these two, either towards left or towards right. But in the question it is given that it is towards right. So you have to draw a line towards right. So you have to draw a line perpendicular to BC and of length 7.5, so equivalent to 7.5 meter per second. So this is that line. So this is the velocity of BC. So how will you represent it? Using a small letter B and C. So the center is C and the end is B. So you have to start from C and B. So mark C, B. Okay, this is velocity of BC. Next is velocity of AB. So now 2 points we know, that is velocity of AB is perpendicular to AB and velocity of AB is passing through, or it is between points A and B. These are the two known things. So using that, we can say here we have one point of that is B, and also we know the direction. So definitely the velocity will be a perpendicular to AB passing through B. So you draw a perpendicular to AB through this point, that is this perpendicular. The next and the third component is slider. So slider velocity is parallel to slider, that we know that slider is horizontally moving, so its velocity will also horizontal, or this. Then again, from where slider so the first point about slider velocity is the velocity direction is horizontal. The second point is the slider velocity is between points C and A, or velocity will be represented as CA, because C is a fixed point. Don't confuse, C is here only, but since it is a fixed point, all points are same. So here also we can say equivalent to point C. So from that point, or again you can remember, all fixed points are same in velocity triangle. So this is the fixed point. So the second point about slider velocity is slider velocity will start from the fixed point, and also it is horizontal. So this is the fixed point in your diagram. Draw a horizontal line to represent the slider velocity. So these two lines meet at a point, and that will definitely what? A, small a. Now you join BA and CA. This is your velocity triangle. Then you can measure AB and AC or CA. These are your answers. So C to A is a horizontal line that is representing velocity of slider. So that is your answer. What is velocity of slider? So you draw it and measure it and write. There will be a conversion because CB is equivalent to 7.5 meter per second. So if you draw 7.5 centimeter, you measure this CA and convert it into meter per second or whatever. Okay. So write that answer in meter per second. That is your first part. And also note the velocity of AB that is required for drawing the acceleration diagram. Okay. So after noting these values, next step is to draw the acceleration diagram. So before acceleration diagram, we have to find the input requirements for the acceleration diagram. So the input requirement are, here we have input velocity is a requirement. So CB velocity. So in that case, acceleration of CB is the input. So you have to find acceleration of CB from the given data to start the acceleration diagram. So the details of that components I will show now. You can note down that and we will continue to the acceleration triangle. Okay. Now these are the values required to draw the acceleration diagram. So this is from beginning only. Velocity of BC is velocity of B, that is omega BC into CB. So you'll get 7.5 meter per second. This is required to draw the velocity triangle. Now from the velocity triangle, the measurement, you should get the velocity of AB as 4 meter per second. So approximately this you should get. This is an answer from velocity triangle. Okay, please note down. Then to draw the acceleration diagram, what you have to find. So we have to start with the input link. So input link is crank. So you should start with the acceleration of crank. So what is acceleration of crank? It has two components, tangential component and radial component. So what is the radial component? Magnitude V square by R, or velocity of crank divided square of velocity of crank divided by the length of crank. So radial component of BC is V square BC by CB. So you will get it as 562.5 meter per second square. Okay. The next is tangential component of the same link, input link crank. So AT of BC, it will be equal to R alpha, or length of crank or length of link into angular acceleration of link. So angular acceleration is given in question 1200 radian per second square. So that is into CB, length of crank 0.1. So you will get 120 meter per second square. So these components are perpendicular components. Radial components is parallel to or towards the center, or parallel to your link, and tangential component is perpendicular to this link. So the resultant of these two will be your actual acceleration of BC or crank. So note these values. Then next value you should know is radial component of AB or connecting rod, because velocity of AB is obtained from the velocity triangle, that is 4. So radial component will be V square by R. So you can use that expression V square of AB divided by BA, that is 4 square divided by length of AB, that is 0.3. So you will get radial component of AB as 53.3 meter per second square. Then what remaining? Tangential component of AB. Tangential component of AB is R alpha. R is the length of AB, that is known, but alpha is angular acceleration of AB, that is not known. So that you have to find using acceleration diagram. Then what is else remaining? Acceleration of Sider. Acceleration of Sider also having one component only. There is no separation of AR and AT. That is linear and only one component. That is also unknown. So that unknown, that is acceleration of Sider and tangential component of AB, are the unknowns. So these two unknowns you can find from acceleration triangle or acceleration polygon. Okay. So we'll go back to the diagram. Okay. Not all these values in your book. Find you yourself find and check whether they are same and not. Okay. Okay. Now you got all the values. So the next point is you have to start drawing acceleration diagram. So the first thing is acceleration has two components. Here crank also two components, radial and tangential component. Radial component will be parallel to the crank or towards center. So the radial component of BC will be from B to C, and tangential component is similar to the velocity component, that is perpendicular to what link. Now first you draw the velocity acceleration of BC. First point is you draw a line of equal to, we'll start with the radial component. So radial component is given as 562.5 meter per second square. So you have to draw that length convert into some value 562.5, and the direction is from B to C. So you draw a line, say from here to here and parallel to BC. Okay. So first you mark the point C dash, because you will always start with this, the fixed point, and you use C dash for point C in and lowercase c with the dash for acceleration diagram. Okay. So mark that arbitrary point, then draw a line which is towards center, that is downwards and parallel to BC. So this is that line, and this line is 562.5 meter per second square. This is the first step, and mark point. Not at marked point. So this is the radial component. So the next velocity, next acceleration is tangential component. So tangential component of BC is it is also noted. The value is about 50 and 53. Yeah, 53 meter per second square. So what about the direction of tangential component? To the same direction of velocity, that is towards right. So you draw a line from here towards right. That is the second component. Okay, that is this line. This is not 53, sorry, 120 meter per second square. 53 is for the next link. So please note in your the values are there. Okay, please note 53. I think for the AB only. So this is 120 meter per second square. Now, sorry, the text is just displaced from the position. So this is only for the reference. Okay, this length is 120 meter per second square. So this is 562.5. So we drawn the radial component of PC and tangential component of PC. Then we reached this point. These two are vector. So what we can say, this point is your end point. That is B. B dash. Okay. So you draw a line, a solid line with the arrow to represent the acceleration of crank. Okay. So these two are thin lines. This is thick line. You can draw these two as dash line and draw a normal line. Otherwise, you have to draw very thin line using pencil and draw a thick line using pencil to differentiate the components and resultant acceleration. So we started with the radial component and tangential component. These two should be perpendicular. Okay, radial component is parallel to BC. Draw a line parallel to this, and perpendicular component is perpendicular to BC. Tangential component is perpendicular to BC. Draw a line perpendicular. This should be perpendicular only. Okay, so we got the acceleration of CB. The next step is acceleration of AB. So what should be the acceleration of AB? Again, we have to think two components, radial component and tangential component. So from we know the radial component is known for us and it is noted, that is 53. So radial component is known, tangential component is unknown. So we will start with the known component. So what will be the radial component of AB? It is towards the center, parallel to AB and towards the center. So parallel to AB means this direction, towards center means towards right, because we are moving from B to A. So the direction will be towards B. So a line towards right and parallel to AB will be the radial component of what? AB. And it should start from point B. That is the next point, known point. It should start from point B, B dash in the acceleration diagram. So from B dash you draw such a line of length 53.3 meter per second square. Okay, this line length is 53.3 meter per second square, and this represents the radial component of BA. And note this line should be parallel to BA. The next component is tangential component of AB. Tangential component of AB is first known thing is perpendicular to AB. Okay, and it should start from B, or it should not start or end. It should start from B or end in A, because BA are the end point of the resultant thing. So the first point is enough to draw, because you know that tangential component is perpendicular to AB. So one component is this, other component is perpendicular. So this component is parallel, so other component is perpendicular. So draw a perpendicular line from this. That's all. You can draw in any direction, but in only one direction it will meet, so there will not be any problem. So I am drawing a perpendicular line to represent the direction of tangential component of AB. Now finally we have the third link, that is slider. So what about acceleration of slider? Again, slider is moving with linear velocity. It's not a rotating component. So the acceleration will also directly the linear one. Now what will be the direction of that? Horizontal only. So slider acceleration will be horizontal. And second point is slider acceleration will start from the fixed point of the diagram. So fixed point of the diagram is C or C dash here. So this is the fixed point. So from here you have to draw a horizontal line. In both directions you can draw. So it will meet only in this direction. That means two components of your velocity and two components of your acceleration acceleration of AB and slider acceleration meets at this point. So what we can say, this point is the unknown point A dash. So mark A dash, and again that component is drawn in the same color with arrow. So this is radial component, tangential component. Now you draw the resultant component A dash B dash. So A dash B dash will be the resultant acceleration, that is resultant of these two, simple resultant of these two components. So drawn, also the slider acceleration joint with the thick line. Now this is your acceleration triangle, and the question you have to find the acceleration of slider. So acceleration of slider is this horizontal line from C dash to A dash, C dash A dash. You measure C dash A dash and convert to the correct unit and write it as the answer. Okay. Then another question asked is angular acceleration of AB. So how will you get angular acceleration of AB? You have the tangential acceleration. Now we found out the tangential acceleration. The angular acceleration is related to tangential acceleration such that what was the equation? AT equal to R alpha, right? So R is the length of AB. So length of AB into alpha is tangential component. Therefore alpha will be tangential component by length of AB. So tangential component, again just now we found out, you measure this distance from here to here. This line is your tangential component. Measure this and convert to unit, a correct unit, and divide it by AB. You will get the answer, angular acceleration of AB. Okay, that's all. So this is how to draw a acceleration diagram. So the change from velocity diagram is, in acceleration diagram, even it is a triangle. For this case, there will be components. Okay, so here you can clearly differentiate that component because of these two different color and different thickness. You can easily differentiate. These two are components of BC and these two are components of AB. And slider, third one, have no components. This is only one component, not two components. So there is only one thing, that is your linear acceleration. Okay. Now again, some may think that a doubt. Some may think that why we draw from C dash to away from C dash, right? Even though the radial acceleration direction is from towards center, that is towards C, but you are drawing from away from C. So that you have, if some may have a doubt like that. So for them only I am telling, don't that is because this is the actual point and this is a point on the diagram. In the point in the diagram is representing the fixed point only, and that's why that is a main differentiation. Therefore you don't have to confuse, because here we are mentioning the direction only. Direction is downwards, and copying the direction only. So when you draw a direction downward, instead of your so remember, you are not marking C dash, but you start with drawing this line. Just think like that. Then you draw the other line. Okay, so you have started with one vector and other vector, two perpendicular vectors. So the third vector, closing side, will be your resultant vector. Then you draw the resultant vector and this will be in this direction only. So after this, if you suppose naming the points, then you will understand that you can name this as C dash only, because this is the fixed point. So the acceleration will be from fixed point to this. Okay, clear? That's all. That's why we are using, always start all even it is velocity or acceleration, irrespective of the point in the diagram, we have to start it from the fixed diagram and draw it to the moving end. Okay, so this is starting from C, drawing to the move end. C again here also C started from C, drawing towards the movement. So slider velocity or acceleration also like that only. So slider velocity is moving towards the started drawing towards the moving point, because A is the moving point. So you should never draw towards the fixed point. That is a opposite direction. That is wrong actually. Okay, always you have to draw away from the fixed point. So hope this example is clear. This is